Okay, in my previous video I treated equation of motion, and I said I would teach you how to apply them in my next video, and today we're going to be talking about that. So application of equation of motion. I have a question that says a car traveling at 54 kilometers per hour slows down uniformly to a velocity of 18 kilometers per hour when the brakes were gradually applied. Okay, that's deceleration from 54 kilometers to 18 kilometers. So it started at it was moving at 54 kilometers per hour, kilometers per hour. Kilometers per hour. Then it decelerated towards 18 kilometers per hour. So we have it to be like that. So the first question says what is the time taken to cover a distance of 50 meters? 50 meters, time taken to cover 50 meters. And I have a big question too that says what is the deceleration? What is the deceleration? What is the deceleration? So from this now I will just say our initial velocity was what? 54 kilometers per hour. 54 kilometers per hour. So I will convert this to meters per second, which is going to be 15 meters per second. Okay, for those that don't know how to convert that, let me just go ahead and show you briefly. You have 54 kilometers. Let's just say 54 times 1000. So that the 1000 stands for the kilometer there. Then we'll just say 60 times 60. So we'll have it to be 15 kilometers meters per second. Sorry, meters per second. So that is that. And for the final velocity, which was given to be 18 kilometers per hour, that will be equals to 5 meters per second. If you do the same thing, you will get that. So from that very equation, we will just from that very equation of motion that stays average velocity at a distance s at time t. Okay, we'll just say s is equals to what? Half u plus v times t. We're familiar with this. That was the major equation we used to derive the three other equations of motion. So from this junction, I'll just go ahead and substitute. We were given s to be 50 meters, don't forget that. So we'll just say 50. Now we're to find time t. So we have 15. That was that was the initial velocity, 15, plus what? The final velocity, 5. So we'll just say t. So 15 plus 5, we'll have it to be 20. So we'll just say 20. So 2 into 20 will be 10. So we'll just say 10t is equals to 50. When you divide both sides by 10, you will just see that t is equals to what? 5 seconds. T is equals to 5 seconds. So that's that for time taken to cover 50 meters. Then for the deceleration, let's use the first equation of motion, which states that v is equals to what? U plus at. Then from that equation we know that acceleration a is equals to what? V minus u all over what? T. And we were given we were told that the car started at what? 54 kilometers per hour and decelerated to. So we'll just say, okay, v is our final velocity, which we have it to be what, 5 meters per second. So we'll just say 5 minus what, the final and the initial velocity, which is 15. So what we're going to have now is a is equals to what, 15. Don't forget that t now is 5, so we'll just say over 5. So from that very place, we will just see that we have minus 10 all over 5. 5 minus 15, we'll just say minus 10 all over 5 equals to a, which is equals to what, minus 2 meters per second. So from this we can say a negative acceleration is always given to be deceleration. That I'm saying now, or if you don't know it, but that's just it. So if you're saying it is deceleration, maybe not acceleration, you can just say deceleration. Now there's no need to put the minus, we'll just say 2 meters per second squared. Alright, so that's just the deceleration that we get. I hope this helps, and it's simple as you can see. So you can go ahead and subscribe for more if at all you're enjoying this. Thank you.